Hello and welcome to a new charter, number 25, episode 15, about how to read an execution plan. Well, we have many cases that our customers wants to know how to troubleshoot a performance issue, right? So, of course, that to read an execution plan is a complex topic because we have many things. But in this video, I'm going to try to share with you some experience how to read the execution plan based on several issues that we have in support. And also it's try to explain a little bit what is the main topics that we need to be aware when you are reading this execution plan. My name is José Manuel Jurado. I am a escalation engineer working in Microsoft and subject matter expert in this technology. So the agenda for this video will be explain a little bit of theory about what is the different topics, the different parts that we need to know when we are approaching, let's say, to read an execution plan to identify what is the performance problem that we have. We are going to have several examples that we have common issues here in Microsoft about issues about what that's mean compilation against execution or versus executions, what that's mean a high number of compilation that is causing some could cause or will cause several issues in terms of performance. We are going to read an execution plan with 4 examples about when we read too many rows, when we are using partitioning, when we need to create a new index, and also I'm going to explain what that's mean the different joins. And finally, we would like to share with you several links that we include several examples or additional information for the topics that we are going to discuss in the next slides. Well, let's start with a little bit of theory. So what happened when I run or when I submit a query against the SQL Server, Oracle, other languages, MySQL, etc.? Well, basically, we have 2 things. First is to compile the query, right? What does mean compile the query? Well, basically, the engine needs to verify it using parse to verify that the syntax, the schema, the permission is valid. After it, they need to bin the objects, means that create a tree about, oh, I need to go to this table, to this table, to this table. And finally, we need to optimize the query based on the different statistics, the different constraints that we have, tables, etc. After it, when we have this phase, we are going to let's say to obtain or to run the execution plan. Okay, execution plan basically generates a series of instructions for processing the query. Okay, so for the reason it's very important to understand this one, the 2 phases that we have. First is the compilation and other ones is the executions. What we explain this? Well, basically is because when our customers say, hey, my query is taking too much time, we need to identify what is the part of these 2 phases that is taking too much time. Is the compilations, because we need to create or to review multiple things, or basically is when we run the query and we obtain the data using memory, I/O, CPU, other topics. Okay, you have an example in our blog about an explanation about it with an example. Okay, So I'm going right now to give an example about what that means.
Okay, let's get started about the difference between compilation and executions. So for this example that I retrieved from our article that we have in our blog, the first thing that I'm going to do is to clean the buffer pool and clean all the procedure cuts that we have. Please don't do it in our environment in production, because it's going to have some performance problem, because we are going to clean all the memory and we are going to clean all the cache. It's just only for example, in order to have always the same results without be affecting about the buffer pool, the data that's in cache, okay, and also the cache that we have when we run when we compile the query. Well, basically the idea is to create a table that is called Academy Block Data. I create this table, truncate table, and also I include several data in this table. And also, for example, I add in this customer table around 2,000 characters in X, Y, Z. And also in the in the age, I include I include a random number between 100 and 5. So I'm going to run this query right now without doing anything or to enable anything else. As you can see here, the query responds very quickly, but right now, as you can see here, is taking time. So the query it's retrieving right now is retrieving the data, taking too much time. But as you can see here, the data is immediately responds. So that means that the compilation, as we mentioned before, about to review the statistics, review the constraints, inner joins, etc. Right now, take no place. It's just only is a pure executions about it. What is possible to know what is doing the query? Well, basically, one thing that you could do is, for example, to enable set statistics, I/O, and time. When you enable these sorts of things, and for example, you run, for example, this query, top 2, as you can see, you are going to have several messages here about several important details when you are looking for about the performance. Okay, is how much time took the whole query, compilation and executions, and also, the compilation and how much time took the executions, let's say, to retrieve the data. Also, we could see here, it's about how many rows, how many logical reads that read this query, right? So for the reason, right now we have two specific things. One is the compile parse. So how much CPU time took my SQL Server to compile and try to find what is the best choice about it. And elapsed time is also include that other aspects about to create the bin object, parse the query, etc. Okay, so right now it's not taking too much time, but let's try to run the query without the top 2. For example, we have some data right now, and let's wait a couple of minutes in order to have this data. Okay, the query finished. As you could see here, right now we have 100,000 rows, and this query took around 2 minutes. If we go here to the message, you could see several details that is very important, right? As you can see here, the query didn't take too much time in terms of parse and compile, but took a huge amount of time in terms of executions. Okay, so also if you could see here about how many logical roads, so logical logical reads that SQL Server reads, means that SQL Server don't take too much time in order to find what is the best choice, but took too much time to retrieve the data from the SQL. Okay, what is we are going to explain with a little bit more. It's about this, but it's a good example when you are using columns that contains a huge amount of data, because the query is taking a few milliseconds, but in order to retrieve all this data and download, for example, I'm working from home today, to retrieve the data from SQL Server will take some time depending on the network that you have, depending on the database that you have, etc. It's very simple if you run, for example, this query. If I reduce the amount of data instead to retrieve, for example, the column customer data that contains all this data here, if I run, for example, just only the ID, as you can see here, the process will take no more than 1 second. Okay, if I go back again to the parse and the data, as you can see, it's taking a few milliseconds. That means that it's important that when you retrieve the data, to think about how much data I'm downloading. Okay, other things, it's when we are going to discuss later, but I would like to give some insight in advance about the different things that we are going to discuss. So I'm going right now to enable, for example, if I want just only to obtain how much time is the compilation, if I click here in the estimated, as you can see here, you are going to see information about, again, how much, what is the data about the compilation, but we are not going to execute the query. Basically, when you run this query, it's just only to obtain how SQL Server thinks that is the best choice in order to approach the data, to retrieve the data. As you can see here, SQL Server thinks that, hey, I'm going to read all the rows in the table and send this data, the 100,000 rows in this table, to the select, and select will go obtain the data. But as you can see here, also we could see the estimated number of rows. Okay, so if you want to obtain more data about what is happening inside, behind the scenes about it, basically, if you right click here and click in show execution plans, you could see several details that about how will be the compilation, and we are going to let's say to put focus about two things. The first is trivial or full. We are going to discuss later, but trivial means that SQL Server is not going to spend too much time to compile the query, because SQL Server thinks that, hey, it's a select start from, I need to retrieve the data basically. Okay, and also you could see here about how is the compatible level of your server, for example, of your database, sorry, and also the query that you have, the query health that you have, the compile size, etc. Okay, so it's very important because right now we are able to see several details about it. So if you want to see what happened about how much time, queries, etc., basically we are going to enable two buttons. First is to include the actual execution plan, and also we are going to include the live statistics. So when you run again this query, as you can see here, we are going to include several details. As you can see here, 1 second. Yeah, 1 second is here. As you can see here, also you could see how much time is taking your query. Basically, SQL Server is reading the data. Right now is reading around 20,000 rows. They need to read 100,000 rows, is reading basically the data, is scanning right now the data of the table and send this data to the select. Okay, so basically is one thing that you know how much time is taking this query when you see this information using the live environment. I'm going to stop here just solely to wait for the completion of the query. Well, the query finished more or less in the same time that we have previously. You could see the execution plan. You could see how much data I'm downloading right now. As you could see, more or less I download around 400 megabytes of data. Okay, you could see several details. And again, if I open right now using the execution plan. Also, I could see how many, if this query is running using how much, because right now I'm using in order to obtain the data. Basically, I'm using one right now. And also, you could see two things that I think that is very important. It's about the weight stats. We could find too much data or too much details about the weight stats, but right now, as you can see here, you have one weight stat that right now is relevant in terms when we execute a query. What does mean async neighbor.io? What do you think? Well, async neighbor.io means is the time that SQL Server counts, let's say, in order to send the data to the client. Every time that the SQL Server sent the data to the client, it started the counter. Okay? So depending on the speed of the network, depending on multiple things, this query or the amount of data that you need to transfer, this weight stat will be more or less. Okay, so other things that you could see, it's about the statistics, the statistics that the SQL Server is using, etc. So the most important thing is to understand what is the weight type, and also, if you want, one thing that you could use is this new DMV that is DM session with stats. If I filter by my session that I'm doing right now, I could see right now for this specific query what is the main weight stats, what is the main weight type that I was waiting for. Okay, so right now, as you could see here, is two things. One is PO is retrieving the data from the storage to the memory, and async neighbor.io means that is when SQL Server needs to send the data to the client. Okay, so it's clear that let's say my bottleneck right now is networking, uh, or I need to think about if I need to receive all the rows, multiply for all the data that I have. Okay, it's obvious, but it's important to think about when we run the query, or when we run the query to avoid select start, use just only retrieve only the data that we need, etc.
Well, the next step is what happens when a query executed. So when we pass the compile process, and what happened? Well, the most important thing is SQL Server is going to consider many alternatives to achieve the query. Okay, this SQL Server estimate one thing that is called cost for each possible alternative. Okay, so as we mentioned, it's going to use statistics, constraints, in order to create the processor tree in order to obtain the tables, the indexes, or they are going to use trivial plan. As we mentioned before, trivial plan basically is when the SQL Server thinks, hey, I don't need to do any special action. let's try to send this one. When we use full, that means that SQL Server spends some time, some CPU time in order to find what is the best approach for this query, right? We are going to explain in another slides, another video, another demo. It's how to find this one. Once we have the input, what is the outcome? Well, basically, the outcome is a set of rules, a set of instructions to run the query, the byte operators. We are going to see, as you could see previously, we saw the operators. We have just only two operators in this execution plan about the select and the executions, etc. It's very important to mention two things. It's about SQL Server is going to choose always the lowest cost, but sometimes if that is not possible because the combination, the process will take too much time, it's going to discard, let's say, or to try to find if I need to spend, I don't know, 2 seconds to find the first query plan, or I need to spend let's say half a second in order to send the execution plan directly to the engine, SQL Server sometimes prefer to do it. Okay, for the reason sometimes we could see this difference. Also, the last part is SQL Server is going to save this query in the cache. So for this reason, sometimes when you run a query, you are going to see, hey, the first time the query took more time than the second time. What happened? Well, depending how you write this query, if you have parameters, SQL Server is going just solely to compile the query without the value of the parameters. So if you run this query for a second time, SQL Server is going to check if this query is in the cache and is going to use the previous execution plan, removing or avoiding to compile again to think about what is the best query. Okay, so for the reason I'm using DB free proc cache in order to be sure that the cache is not affecting. Okay, of course, other factors that we saw in support is even using the T-SQL text, we saw that depending on the options that the customer has in the connection, let's say set it abort or something like this, you could have different execution plans. So when we are comparing the execution plans, it's very important to have the same scenario, same database, statistics, indexes, data, sessions, T-SQL command statements, schemas, etc. Okay. Also, other things that we need to think about when the query is taking, for example, more time than previously, it's different details. For example, parameter sniffing, query parameterizations. These two things, we have many informations about it. Okay, I'm not going to explain this. But for me, I think that it's very important about the plan recompilation. What does mean plan recompilation? Well, as you know, as we mentioned before, when we run the query is going to the cache, SQL Server is not going to recompile again the query if we are using the same text, using parameter or not. Okay, anyway. So, but what happened if I update the statistics with full scan, for example? Okay, we are going to have a new, let's say, a new data that SQL Server needs to compile again. SQL Server knows that the statistics has been updated, and we are going to obtain let's say compile the query. Also, if you use SQL recompile or we have a new index, or when we run the BCC Free Pro cache. One thing that is very important about it is about the updated statistics. Remember that SQL Server in Azure and managed instance is not going to update your statistics. It's one task that you need to do in your environment. Okay, using SQL Agent for MI, runbook, or any other aspect or the script that we have in our blog about to update the statistics and reveal indexes, etc. But it's very important about the statistics, because if the statistics are not accurate about the distribution of the data, most probably SQL Server is not going to calculate the best execution plan. For the reason, every time that you have a case in terms of support, try to update the statistics. Of course, that we could see if the statistics has been updated or not. Okay, but always remember to update the statistics is fully possible. Of course, that we could have a large table, etc. Is another history, but it's very important about it. Well, we reached one point that before review the demos that we have, it's what is the, let's say, the key points that I used to review when we have a performance problem and I need to read the execution plan. Well, we have several decisions about if it's needed to read from the left to the right or right to the left. Well, I used to review the left first, but basically it's because I'm checking one thing, that is warnings. Because sometimes I used to see that customers using selects, using different data types that we have in the table. For example, the customer has bar car in one table, but the parameters is bar car, and we need to convert implicitly this query, or review the estimated number of rows versus the current numbers that we have. I'm going to review the cost of the different operator and put focus or pay attention about the operator that has the most cost, in order to see what happened if I could improve this query. Okay, because it's sometimes we used to listen, for example, that hey, no, you are using table scan, or you are using heap tables. Well, why not? But the most important thing is to review if creating indexes of this table, or creating a cluster index, or creating an index for this heap table, we could improve the query. Okay, so for the reason, this is that the things that I used to review. The other things is the missing indexes. It's clear about it. Is when SQL Server needs to use SQL indexes. It's very important, the missing indexes, also for the statistics, because we used to have cases that customers say, hey, my query working perfectly in the last 2 years, but right now it's not working well. Well, most probably you have more data, and right now the queries needs to have an index in order to improve the performance that this query was needed previously. Okay. Also about the 5 pipes, let's say the arrows, is depending on the size of the arrows, means that how many rows we are going to transfer to the next operator. Okay, so sometimes, of course, for business reason, I need to read all the rows. You need to read all the rows, but sometimes it's important to see why. Okay. Finally, 2 things about the compatibility level, because, for example, in the last test compatibility level, we have many hints, many options in order to improve the performance. If you're using the previous one, of course, it's working well. Why you need to change? Okay, but right now we could see, for example, the new compatibility level is going to perform better than previous one, and sometimes could be different. But normally, let's say 99% of the situations, it's the improve is equal or more the results that we have. In this first demo, I'm going to share with you one typical case that we have in support about one application that is not using any at all parameterized queries. Is all the queries is ad hoc, and I'm going to show you how is the impact when you are doing this. Remember that when you have parameterized that is increasing too much, it's, for example, also when you are using elastic database pools. When you are using elastic database pool or managed instance, for example, assume that if you have a lot of ad hoc queries, it's going to impact because we need to use the cache in order to compile these queries, and we are going to have a lot of plans for every query. Okay, and also you could have some issues about the size of the query data store, about multiple things. So for the reason, it's important to think about if I need to use parametric or not, or try to avoid at maximum that we have ad hoc queries.
In this example, we could use SQLDB, SQL Azure, Managed Instance, AAS, etc. But I would like to share with you, for example, in what happened in SQL on-premises, to give another example that at the end is the same engine in terms of performance, right? So for the reason, I'm going to run a SQL profiler. Much probably you know this. I'm going to filter just only one specific applications. So right now, as you can see here, I have one Python application that basically is going to run multiple queries in a random way, basically running the query. So let's start from test data where key equal something. I'm not going to use parameterized queries. Basically, I'm going to run change this value for the value that we create randomly. So I'm going to start this application. It's going to run in multiple threads. And as you could see here, you could see right now what happened in your database. So we are running multiple queries using multiple values without running in as a parameterized query. So this query is running well. I don't have too much problem in these executions. But as you could see here, you could see how many plans that we have right now based on this query. So as you can see here, we have, sorry, not this one. 1 second. This one, sorry. Yeah. So you could see what happened for my database. Every time that I don't have parameterized query, SQL Server needs to compile the query, and it's taking a few milliseconds about it. Right now, I have 44,000 different plan cache. Okay, meanwhile my application is running. So you can imagine that when we have a huge amount of databases with a huge amount of running queries in terms of ad hoc, also we could see right now how is the impact in terms of memory that right now my SQL CFP cache processor or procedure, sorry, about how many plans that I have. Okay, so it's very important. Think about it. Okay, so for the reason, always all recommendations is to use parameter query when it's possible to do it, of course.
In this first demo, I'm going to share with you one typical case that we have in support about one application that is not using any at all parameterized queries. Is all the queries is ad hoc, and I'm going to show you how is the impact when you are doing this. Remember that when you have parametric that is increasing too much, it's, for example, also when you are using elastic database pools. When you are using elastic database pool or managed instance, for example, assume that if you have a lot of ad hoc queries, it's going to impact because we need to use the cache in order to compile these queries, and we are going to have a lot of plans for every query. Okay, and also you could have some issues about the size of the query data store, about multiple things. So for the reason, it's important about to think about if I need to use parametric or not, or try to avoid at maximum that we have ad hoc queries.
Well, right now, let's try to practice all the lessons that we received previously. Well, basically, we have right now this query that basically it's very simple. The query. This query is joining two tables, change item with change group. We obtain some data from the different tables. We join the data using the ID of the change group with the change item for the group ID. We are going to filter using the group number one. And after it, we are going to order by or to obtain the data in short order based on the create date of the group plus the ID of the change item. So we enable, as we mentioned previously, we enable the live query statistics and the current execution plan. We are going, please, as we remember before, please don't run these queries, these two things in your production environment. Okay, just only if you need, it's very urgent or something in order to test these sorts of things, but we are going to remove all the cache of the query, and also we are going to remove all the data that we have in the memory. Okay, so I use this one just only for in order to don't be affected in terms of buffer cache, etc. So I'm going to run the query, and as you could see here, we have the first thing that we need to pay attention, right? So right now this query, well, the process is running 37%. Right now, we obtain results. As we mentioned before, is not right now the issue, is not the compilation, is the pure executions. Okay. Also, in the live statistics, we saw that we run a table scan, read all the rows of the table, also of the change item. These two things are in it's a heap tables. Okay, as right now we don't have right now any cluster index, etc. We run these two objects means that we run in parallel. That means that if we have more than one, because we are going to run in parallel using multiple threads, this query. The half mash means that as I need to short the data, um, sorry, as we need to run the inner join, I need to run the hash mash in order to let's say join the tables in just only one single, let's say, results or result set. And after it, as you can see here, it's about the short. Sure, as we need to run the order by, as you can see, we have the short because SQL Server needs to short these two columns in order to send the data to select using running in also running in parallel, as you can see here in this icon. So basically, this is the query that is running. Also, when you run this query, you could see the missing indexes that right now SQL Server thinks that just only for the impact to improve the query 40%, 14% of the query, we need to create this index. We could obtain this index here, clicking the missing index details, and we could see this one. Also, SQL Server, sorry, I would like to share with you several other details about this execution plan, but as you can see here, it's very clear, right? I need to read two tables, join the data, send the data to the short the data, and set the data to the select. And the end, these fat, let's say, pipes means that how much data I'm transferring from the different operators. Right now, this is sending around to 100,000 rows. This is sending to millions of rows, etc. Right? So also, if you want to see about the execution plan, you could see multiple things about the estimated. As you can see, as we mentioned before, is full optimized. So SQL Server spend time in order to compile these sorts of things. We know right now, for example, the degree of parallelism means zero that is going to use more than the most that we have right now. Also, we could see the statistics information here and when was updated. Here is very important when you saw these such of things means that perhaps you need to improve or you need to update the statistic because it's not 100%, it's 12. It's good to have 12. Well, depending of the accurate of the statistics, but it could be good. So it's depending the situation. But when we are talking about the performance issue, it's good to have all the statistics updated. As we mentioned before about the weight stats, we saw again the async the IO, etc. Of course, that if you need more information about to obtain the properties of the execution plan, you could see other things about the properties of the properties, about the executions, etc. Okay, but right now, the most important thing right now is about what is the time that I spend it to run. So as we mentioned before about our slide, the best thing is, hey, do we have any warning message? Let's say that no. Do we have any misindexes? Yes, but it's just only 14. So makes no sense to create this index. You could create, but seems that it's not the best approach or to the best option that we have. Do we have, for example, any operator that is taking too much time? For example, here we have 0 seconds, 5 seconds, and yep, it seems that the short is taking around the almost all the time that it's spending to receive also this data. So for the reason right now, we could improve or try to improve the query using the short, because right now we don't have too much data. Other things that I have learned working with statistics, it's about when we filter this data, it's about how many different values that we have for this row. Because if this value in this table contain more rows that we have for another data, most probably the execution plan will be something different based on the statistics, based on the distribution of the data based on this value. Okay, so sometimes when uh, um, when I have a performance problem and we have a filter, this word clause, the idea is to see how is the distribution of the data. As you could see here, I saw that the group number one contains more rows than other ones, right? So what that mean? That means that if I change here the value, let's say I'm going to clean again. If I change the value to 2, as you can see here, I have another different message. Hey, so because right now SQL Server, based on the statistics for this reason, is very important, thinks that the way to the approach to find what is the best execution plan is to do in another way. It's, for example, go to the change group, try to obtain the data, filter the data for the time scan, and filter the data here. As you can see here, we have less rows, the short take less time, and the query is taking 2 seconds to be completed. So really amazing. Even we could see other these indexes say, hey, if you create this index, we are going to improve other possible queries, not just using 2, using 3, 4, or 5. So create this index based on to create a group ID and ID. As you can see here, we have this. It has very logic to create this one, because group ID I'm using in order to join the data in the change item with the group. So right now, an ID is the code of ID, because this table is it's a heap table. So we don't have any primary cluster. But let's try to create this index. As you can see here, you are going to see another execution plan, right? So if I run the query, okay, the query is totally different. It's totally different because we have just only 5 rows. Right now, the query is different, and I have other ones because SQL Server say, hey, SQL Server needs to update to create another index, filtering by issue ID, okay, and also using the create table in the cloud in the included counts. So if I create this missing index again, I'm going to clean the buffer again and also all the probe cache. But as I create a new index, I'm going to have a new execution plan, of course. And if I run this query is totally different. It's taking less than 1 second, and I use it index seek in order to, as you could see here, in order to obtain the filter by issue ID. I'm going to use another about filtering the data with the ID. I'm using heap tables It's taking a few milliseconds. Okay, let's try to use, for example, what happened with the value 1, right? If I run again the query, as you can see here, something is different. We have just only 8 seconds to complete everything, but again, the short operations is taking too much time. Okay, why? Because right now SQL Server needs some time in order to short around 3 millions of rows from create table and ID. We reduce the time, of course. Okay, we use parallelism, of course. So all these such of things, we improve the query because this specific group contains more data than we have others. Okay, so finally, I would like, as we did previously, if you want to see how much data, also how much resources that you are using your query, you could use the session ID or you could use the resource stats in order to see what happened with your queries, what is the impact when you are executing the query, etc. Basically, I would like to, when you have this short data that it's not possible to optimize, and you have this volume of data, if for me 25 seconds to obtain all the data, to transfer the data and obtain the data here, I think that is good the number. But if you want to improve, this query, also you could use one thing that is called indexed views. What does mean indexed view? Indexed view is like to materialize the data that you have in a view, that this view is going to have data. It's not going, normally when you run the views, SQL Server needs to retrieve the data from the different tables, run the magic and obtain the data. But in this case, when we use indexed views, that means that all the data, instead to query the tables that is behind this, the definition of this view, we are going to have directly the data, calculated the data. For example, in this case, I'm going to have this index view. Right now, this view contains already the inner join of the tables. Right now, I'm going to create two indexes of these indexed views. And when I run the query, you are going to see another big difference in this execution plan. When I run the query again, is this one is here? Yep. I'm going also remove the cache. Yep. And okay, I'm going to run this one. And as you can see here is another history. So I reduce all the time in terms of inner joins, in terms of CPU. Right now, I am still about the short data. Okay, so in this situation, SQL Server is going to have more or less the same time that we spent previously, because again, we need to short the data and also we need to obtain all this data. Okay, of course, we could reduce much time. It's, for example, when you run the query, if, sorry, I forgot to think one thing. As you can see, even when I choose these two tables, it SQL Azure or SQL Server identify that we have an indexed view that covers the queries, the data that we have here is going to use this view instead to use the tables. Also, I forgot to say one thing. It's about this query. We have an exclamation marks here that mention that, hey, my problem, I have a warning. As you could see here, say, hey, I need to use 10 dB because you don't have memory in order to run this query. Okay, so if I want to improve more about it in terms that to give the maximum performance about in this query, you could use also the max grant percent. That means that you are going to use the maximum capacity for the buffer pool for the queries in order to obtain the data. So when we run this query again, we are going to see right now several other examples. We are going more or less, we are going to have the same time in terms of executions, but we are not going to have the warning message, and the execution will take more or less, as we mentioned, the same time. So right now, it seems that the main goal is the source. So it's a pure executions. And of course that we have other ways is to create, for example, we could create when you insert the data, update and insert the data, try to enable a trigger or try to define a trigger to create this table directly, okay, for example, in order to reduce the data, okay, to reduce this performance, for example, right? So as you can see here, we have many other situations. Also, we could create another cluster index in order to use to show the data about the issue ID and grade ID. That in this example, when if we run again this query, we are going to have other approach in order to try to reduce the time that we spend in order to show the data. Okay, as we mentioned, we could do several actions, but at the end, all of this query is at the end is a pure execution. We could increase the number of CPU. Most probably, we increase the number of CPU or we increase other things. We are going to have this time. So the last point to finish this presentation, also, as you can see here, that we obtained 2 millions of rows here. Also, we started in these sessions about to reduce the number of the data. So, for example, right now, if I filter by the number 1, why I need to include this in my table? No. So if I remove this uh, this uh, this this field because there is no need for me to use this one, why I need to do this one? Also, for example, this ID will be always, in this case, in this data, will be always the same. So also, I don't need this value. Okay, so if I run again this query, let me run again. 1 second. Run this one, run this one, and run this. As you can see here, uh, right now, when I create the indexed views about this indexed view, I create this index in order to reduce also if I create this index in this indexed view that we have all the data in one index. As you could see, I'm filtering by user ID, create an ID, because the ID in this indexed view, the ID is the chain ID. So change item ID. Create is the column that we have in the for the change group. So at the end, I have one index in this view that contains the join of two tables that previously took 25 seconds, or I don't remember exactly how many, in order to obtain 2 millions of rows in a shorted way. And right now I have 20 seconds. 20 seconds that if I run again in terms of message, right now, in terms of parse executions, is nothing, but in terms of executions time is around 18 seconds. It's basically is because I'm retrieving 2 millions of rows to my PC from the SQL server, right? So again, we started from the beginning that right now is not compilation, is a pure executions, okay? Because SQL Server needs to do these operations about it. Of course, that if we run this query using the value 2 with all the improvements that we did, also, well, it's not going to have any time because SQL Server is going to improve all the data without any issue. Even, sorry, I forgot, I didn't use the previous one. 1 second. Not this one. Sorry, I think that, yeah, this one. Sorry, with all the improvements. Okay, it's just only 1 second in order to obtain this data. Sorry, no, it's with the value 2. Sorry. So it's not taking too much time. Okay, so for the reason it's very important, of course, that as we started at the beginning, it's the execution plan is a complex, of course, but the most important thing is to know how is the approach of the queries. Okay, using the, let's say, the logic, you could try to figure out what happened in terms of executions, in terms of the data. Of course, that if we run this in a virtual machine in Azure, in the same region that this database is, much probably I'm going to reduce the time because, as I mentioned before, I downloaded data in my SQL Server Management Studio, right? So for the reason, as we mentioned before, it's very important. Let's try to think about how is the approach of my query. Basically, it's nothing magic. It's try to use your logic about it.
The last part of this demo, I'm going to share with you two things that I think that is important about SQL Server. So for the reason, we are going to use one of the most famous tools that we have about Power BI in order to capture data using direct query, right? So as you can see here, we have defined all the relations. I obtained this data from MethodWorks. Also, I have right now the table sales contains around 234 millions of rows, and I have a relation with the dimension date, okay, in order to obtain some, let's say, summary about dates, etc. Okay. One thing that you could see here is very important, the difference between cluster index and are not cluster column store index. When you're using column store index, beside that, in terms of OLAP, it's more faster to read data. It also is in terms of question of the space, right? But let's try to put focus about these executions. So the main idea is I'm going to give two insights about what is the usage of the partitioning. Okay, you could find multiple information, but we are going to see how to implement this one. And also we are going to review we have two databases. We have database one and another one. This first has not any optimizations done. Another one contains all the optimizations using, for example, partitioning. So we are going to study the execution plan, and we are going to provide several details how we improve the query that we receive from Power BI.
Well, the last demo, as we mentioned, we are going to use Power BI in order to have one report that is filtering by 3 different months and years. The idea is to obtain the stock item, the name, and also how much or how many products that we sold from this item. We create dimensions, etc. And right now, this is the information that we have. So this query is taking too much time right now. Okay, so we are going to 1 second. We are going to clean the buffer. 1 second. We are going to use two databases. The first database that we are going to use is B1 that contains the data that has not any optimizations. This database right now it's a hyperscale database with 6 cores, and the another database that contains all the improvements has just only 2 cores. Okay, so I'm going to run this query. This query is the same query that Power BI said the SQL Server that we obtain using SQL Server or SQL Managed Instance or SQL DB, but in this case, that Power BI sent to Hyperscale. If I run the query, including the actual execution times, as you can see here, we have the same process. Right now, if we start from the left, we don't have any warning message right now, but as you can see here, SQL Server, SQL Server is reading these 234 millions of rows to obtain the data. First, they review the table of the dimensions, go to the fat cell in order to obtain the data, etc. Right? So as you can see here, we could see several details about it. So let's try to run this query in the database that we don't have any optimizations. So the first things that you could see is taking time, right? So right now, SQL Server is trying to find what is the best approach to obtain the data based on the statistics, etc. Okay, even right now, if I run this query, you could see that SQL Server is using more CPU. Okay, and also if we filter what happened internally in this query, we could see that right now the almost time is reading data from the storage to the memory. It's POLADS. POLADS mean take data in page format from the storage to the memory. Okay, also most probably we are going to increase the CS consumer because as we mentioned before, when we are running in parallel, this is the typical weight stats when we saw in terms of parallelism. Okay, so right now this query took around 1 minute and 20 seconds. As you could see, it's pretty much is the same that we did in previous. In previous, we don't have any warning message. We don't have any index. It's basically is a pure executions about, okay, as we join the data with dimension, I need to read dimension, need the table fat sales, send these 234 millions of rows to calculate the sum, create a hash because I need to join these two tables. Again, try to obtain more data. Also, I need to use the table about the stock in order to obtain the name of the product. Uh, Again, join the data using hash mash, join the data and retrieve around 657 rows to obtain this data, right? As you can see here, we obtain all this data. Okay, so what happened when we review the execution plan? As you can see here, one thing that pay my attention is about the cost. The cost is 96%. So it seems that all the process that is taking is this. As you can see here, SQL Server is reading all the rows. All the rows to filter about the delivery date key. So in order to obtain just only the rows, the sales done in this, I need to read the 234 rows. So it's too much, right? So for this reason, in this case, uh, when we have this approach, we could say, hey, what happened if I split the data in different partitions? Partition means that you are going to have data in the same table. There is no need to modify anything. Is I have data from the fiscal year 2013 August, 2014 August, and 2015 August. So I need just only to, let's say, to my approach is to read this data instead to read all the rows that I have in the table, and after read, filter the data. So for the reason, I'm going to open a new. So let me just only to see what happened at the beginning and then at the end. CX packet about parallelism, PO large to retrieve the data, CPU usage, etc. The most normal situation that we could have. So let's try to copy and paste this query, but using the database that we have already created and partitioned. We are going to enable again everything, and I'm going to run this query. Remember that this query is using just only 2B cores, right? So as you can see here, we are going to wait for a couple of seconds in order to obtain all this data about it. Well, this query fits in 56 seconds. We obtain the same results in terms of executions, okay, in terms of values. As you can see here, the execution plan is pretty much is the same, but we have here a big difference. The cost, instead to read 234 millions is reading just only 203 millions. Okay, because as you can see in the SIG predicates, it's using partitioning, okay, to read the data. Okay, remember that also this database has just only 2 vectors, okay, not 6 vectors that we have in the previous one. So much probably, as we are using parallelism, and right now, if I run again this query for this database, it's 17. Yep, it's 103. Okay, 103 here. As you can see here, it's basically is to obtain data because with 2 vectors, well, it's not possible to do more, but right now it's more reading the data. Much probably, if I'm not able to clean the buffer, if I not clean the buffer, much probably I'm going to improve a little bit this query, right? As you can see, we have around 30 seconds of completion because this query took 57, and here the query that we run with a database that is not has any improvement is around 120. Okay, so it's at least we improved something as we mentioned before. Also using um, other things, we could improve a lot. One thing that also, if you run this in a cluster store index plus partitioning, most probably you are going to have more or less for this query in 10 seconds, okay, with the same number of records too. Okay, so right now, as you can see, it's one thing that we changed, the message is think about how SQL Server approach data, or what you are going to, as a DBA, let's say, or as a data engineer, how will be the approach of the data to take the data, right? So for the reason, all this improvement at the end is going to reduce reduce the data. But as we mentioned, basically this execution plan is very simple. Okay, take data from the dimension table, read the data from the index from the fact table, join the data in 2 ways using parallelism. And the end, when we have this, let's try to aggregate the data to obtain the count. Give me the details about the stock, etc., and run the filter to obtain the old data, short, etc., and we have the data. Okay, so for the reason, and the end, the message is think about how to is the best approach in order to improve the execution of your queries.
Well, we reached the end of this session. You could see how many related links that we have about the logins, about SQL performance, etc. Also, I include several in this link. You could see all the operators that we have about the logical and physical operators about it. And well, if you have any questions, please feel free to send an email about any doubts that you could have about execution plans. As we mentioned before, my main thoughts, my main idea was to give some insights how to review an execution plan, try to use the logic, how is the approach, how much data I'm using, what is the possible to create indexes or not, and try to understand what is happening behind the scenes. We are using heap table, so of course that much probably we use cluster indexes, etc. We could improve a little bit more if needed, etc. But always is depend. Also, finally, if you use the max top, it's going to also to give other insights about it. But well, we will try to explain a little bit in this session. Again, thank you so much for spending your time in this session. As we mentioned, let's see if we see you in another video sessions about it, and thank you so much.